Hola, algebra people. I hope you're doing well. Here is today's installments for lesson 3-2. And we're going to be talking about these fun things called zeros. So let me first give you some other words as well. So in math, we also have these things that we call roots, solutions, and x-intercepts, right, as well as zeros. All right, all of these mean the same thing, okay? So they are all synonyms for each other. So zeros is probably the most popular, but if you see roots or solutions or x-intercepts, know that it means the exact same thing. Okay, so you can read through this problem up here. Also, while we're talking about synonyms, remember we did this when we talked about function notation, right? F of x is the exact same thing as y. All right, so these two are also synonyms. Okay, so let's take a look at what we've got for today. We're going to graph these, and it just says find the zero for each one of these linear functions by graphing. So however you want to graph these, intercepts, make a table. I suppose I'll do both, and we'll go from there. So first one is 3x minus 3 equals 0. And you're thinking, well, I don't have a y in here, so I really can't use intercepts. But remember, if you look above, it says, hey, get your equation equal to 0, and then once it's equal to 0, right, 3x minus 3 equals 0, now you can replace that with f of x, right? Or what I said earlier, you can replace that with y. And so now you can think about this a couple different ways. In terms of, all right, hey, I'd like to graph with a table, or I'd like to graph with intercepts. Okay, so whatever you prefer to do. Since we've got this method, we might as well go back to the table format. So here's x. Instead of calling it y, I'll be politically correct. I'll call it f of x. I don't see any fractions, so -1, 0, and 1 should work out just fine. And so we've already got it set equal to 0, right, which now turned into f of x. So if we plug in -1 here, what do we get? We get 3 times -1 minus 3, and that has to equal f of x. So 3 times -1 is -3, -3 minus 3 is -6. All right, we'll plug in a 0. 3 times 0 is 0. Right? Then we will subtract 3 and get -3. And then we'll plug in a 1. 3 times 1 is 3. 3 minus 3 is 0. So there's your points to graph. So -1, -6. Looks like it doesn't even fit on my graph. However, 0 and -3 will be right there. 1 and 0 will be right there. Ba-bam. So find the zero of each function by graphing. So here our 0 is, where does it cross the x-axis? Well, it crosses it right here, and that is at the number 1. So 1 is your answer here. Number 2, we've got to do some manipulating on number 2 to get everything together. So let's move the stuff, as I like to call it, over here. Right? Let's move both of these over here. So we're going to add 2x. And we're also going to subtract 5. So we'll add a 2x. Oh no, all of a sudden my x's have disappeared, haven't they? Because I'd have -2x plus 2x. We can subtract 5. 1 minus 5 is -4, right? And that's equal to 0. Okay, remember, when we get this set equal to 0, now you can say, hey, -4 equals f of x, right? Or you could say y equals -4. Ooh, -4. Ooh, that's aggressive. And if we graph this line, kiddos, it's just a straight line that goes through -4. So find -4 on the y-axis, 1, 2, 3, 4, right about there. Okay. Does this line go through the x-axis at all? Sure doesn't. So does it have a 0? No. So you can just put on here, no 0. Okay. Next one. This one's already set up pretty well for me, so we can say negative x plus 4 equals, right, f of x. And go ahead and make your table if you'd like. So we'll have x, f of x, and let's go negative 1, 0, and 1. Same thing. So we plug these in here. This is negative 1, and you can think of this as a negative 1x. So negative 1 times x, or negative 1, is really a positive 1. Plus 4 gives you 5. 0 plus 4 is just 4. And negative 1 plus 4 is 3. So let's go ahead and we can graph this one. Ooh, sorry, that is, nope, that is not where that point should go. All right, there we go. Negative 1, 5, I believe. There we go. Now we're at 0, 4, and 1, 3. All right, and it's not a very straight line. Voila. There's our line for that one. So this one goes through 1, 2, 3. Looks like 4. All right, is our 0 there. Again, make sure if you need to use a ruler. I obviously didn't. My lines were disgraceful. So there's page 1. Again, things to remember: f of x and y are synonyms, as are roots, solutions, x-intercepts, and zeros. Cool. All right, so I'm going to do page 2. Like magic, that will appear here in just a second. Kaboom. There it is. All right. So now we've got some graphs, and now we're asked to find, some exact answers or zeros or roots or solutions. And sometimes our graphs don't really help us, right? Like if I zoom in here and said, kids, what is our x-intercept of this graph over here, right? Well, we know the x-intercept, right, is right over here somewhere. But you can't really tell me what number that is precisely, can you? You can say it's between 2 and 3 and probably closer to 2, but we don't really know. And so this is where if we do have an equation, we can solve that equation for x, and we will know exactly what that number is, right? So let's take a look. Let's take a look here at this one and see what it says. So we're walking towards a ranger station, and we know that they've given us this equation here, right? D equals 7 minus 3.2 t. Just because we don't see x and y, or x and f of x, don't be fooled. They're still there. They exist just like they do. Okay? And you see they've made a nice table here, and they've graphed it, and that's very similar to what we were just doing. So hopefully you're not confused at all as to how they got this graph. All right, but it looks like this. And we want to figure out, okay, what exactly is this root or this 0? Well, all I want you to do is let's take this equation. D equals 7 minus 3.2 t. And let's think about what we would do if we were going to solve that equation. Remember, right, from our table, right, maybe this will help us make a little bit of sense. We've got to kind of think backwards. So if this is x, the t values, and d is that f of x, well, remember, before we called it f of x, we had a 0 over there. So you can think of this, right, just like this. And this is what we do when we solve these. If you want to find the 0 of an equation, you set the equation equal to 0, and you solve it. So how would we solve this equation for t? Well, let's move 7 over to the other side. So let's subtract 7 from both sides. Right now it looks like negative 7 equals negative 3.2 t. Right, and then what would we do from there? Well, then we would just divide by negative 3.2. When we do that, we get a positive number, so that's good. 1.875. There you go. So there's our exact answer. All right. So we know at a time of 2.1875 hours, we will be exactly at the ranger station. Whew. So a lot of talking about that problem there, but I think maybe, hopefully, that helps us when we go to solve these ones down here. So here we go. So Jessica wants to record her favorite songs to one CD. They've given us a function here that C equals 80 minus 3.22n, right, represents the recording time C available for n songs that are recorded. Find the zero of the function and describe what this value means in its context. Right, so in other words, we have, if you look at our graph, they've nicely graphed it for us. Our graph starts all the way up here at 80, right, and we see that right here. So that means we have 80 minutes that we can record on this CD. And the total recording time, right, is what we see here as the letter C. And then 3.22, what does that mean to us? Well, that's the amount of time that we will lose off of our CD for each song, right? 3.22. They've figured out this. So if we want to figure out the zero of this function, let's go ahead and set this equal to 0, and we can find it. So 0 equals 80 minus 3.22n. All right, same thing here. Let's move 80 over to the other side. So we'll subtract 80. 0 minus 80 is just negative 80. And then we've got to go ahead and oh, forgot my n there. And again, how would we solve this equation? Well, just divide by negative 3.22. And what does that give us? So that gives us 24 point, we'll just call it 84, and there's a whole bunch of other numbers after that, 47205. So describe what this value means in context. Now this is, again, we've got to think about what does our answer mean. So we figured out algebraically our 0 is approximately, right, which when you see these two little squiggly lines, right, so that means our 0 is approximately 24 point, I'll just say 8 because that's an easier number. What does this value mean in context? Well, that means we could record 24.8 songs to fill up this CD, but have we really recorded that last song? No, we've gotten, through, 8/10 of it. So we could say at 24 songs, the CD is full. Awesome. That is some bad handwriting. Hopefully yours is better. Let's move on to our gift card ones here, and then we'll call it a day. Enrique uses gift cards to buy coffee at a coffee shop. Initial value of the gift card is $20. Here's our function, right? Find the 0 and describe its meaning. So again, this is kind of probably getting boring for some of you, and if so, just, hey, feel free to skip, move on. Try some of the practice problems. If all goes well, great. If not, come back and watch this. But let's go ahead and set this equal to 0. So again, now we're going to solve for C, negative 2.75C. So we're going to take negative 20, divide that by negative 2.75. We get C equals 7.27 repeating, it looks like. So find the 0 of the function. Well, there's your 0 right there. So 7.27 repeating is our 0. Describe what this means in context. Again, think about what we had. We had some amount of money on a gift card, right? We had $20. And we know the amount goes down every time by $2.75. All right, for each cup of coffee that he gets. So after 7.27, we don't have any more money left on our card. So again, we could just say after 7 coffees, right, that's where he's going to have to start paying for his coffee. He will have to pay. All right, so I think we're good. If you guys want to tackle the next two practice pages, again, the solutions and everything like that are back on the website. So as you work through the problems, if you want to check your work, do that. Ask questions as you need, and we'll go from there. All right, see you.